In this video, we'll discuss the IV characteristics of linear and nonlinear circuit elements. Ohm's law describes the relationship between current I, potential difference V, and resistance R. We can summarize Ohm's law using this equation. This can be rearranged to use the equations to complete the table. Pause the video while you try. How did you do? Here is an IV graph for a resistor or a metal wire. The relationship between current and voltage is directly proportional. If we double the voltage, the current also doubles. It's also important to remember that this only works if the temperature of the conductor is kept constant. We say a wire is an ohmic conductor because at a constant temperature, its resistance is constant. A current flowing through a resistor at a constant temperature is directly proportional to a potential difference across it. A component that gives a graph like this is said to follow Ohm's law and is called a linear circuit component. So what is an IV characteristic? A graph which shows how the current I flowing through a component changes as the potential difference V across it is increased. This apparatus can be used to deduce the IV characteristic of a component. By changing the resistance of the variable resistor, you can change the current in the circuit measured by the ammeter A, and then the voltage across the component can be measured using the voltmeter V. The values obtained for a range of values for I and V can then be plotted. Voltmeters and ammeters used in the experiment are ideal as voltmeters have infinite resistance so that no current flows through them, and ammeters have no resistance so there is no potential difference across them. However, you should know that this is only true in theory. In the real world, when carrying out this experiment, the resistance of a voltmeter will be very high, not infinite, and the ammeter will be low, but not zero. A filament bulb contains a thin coil of a wire called the filament. This heats up when an electric current passes through it and produces light as a result. Do you think the resistance of a filament lamp will follow the rules of an ohmic conductor? Why? Pause the video while you think. No, it doesn't follow the rules of an ohmic conductor because the wire gets hot, increasing its resistance. Here is an IV graph for a filament bulb. Due to the resistance of the filament, energy is transferred, making the wire hot. The hotter the wire, the higher its resistance, so further increases the voltage V, result in a proportionally lower increase in current I. The filament bulb is therefore not an ohmic conductor, so it's a nonlinear circuit component. Here is the symbol for a diode. A diode is a component that allows current to go in only one direction and is called a semiconductor. What happens to the bulb when the diode is reversed in this circuit? The bulb will not light as current cannot flow through the diode in the reverse direction. Here is an IV graph for a diode. In the positive direction, the line is flat until a certain potential difference is reached, and then a steep diagonal line upwards is seen. In the negative direction, it's a flat line on the x-axis. Because no current is flowing, however large you make the voltage, this is a non-linear circuit component. And that is everything you need to know about the IV characteristics of linear and non-linear circuit elements.